is an important part of the class is because it's a major decision. We are now, after today, in module 2 of the course. So the last 3 sessions were kind of foundations, is what I call them. Now, today, and the next 2 weeks, we're going to talk about how do you decide which AI models to use. And they're not all the same. So today, we're looking at a relatively simple dimension, which is the source code of models and the licensing of the models. And then next week, we're going to look at the size of the models. And then next week, we're going to look at performance metrics, okay? So DeepSeek, the reason the stock market dropped $1 trillion, I don't know if it was fully $1 trillion, but it was a better part of $1 trillion in one day, is because DeepSeek was open source. All of a sudden, everybody thought, oh no, these companies are all dead with this. So I'm going to give you a very brief overview of how computers work, computer programs work. Let's see, do you want this higher, or you want this lower, or is this okay where it is? No glare or anything? Okay. So we have high-level languages and we have low-level languages. High-level languages, with one command, you can do massive things. You know, you can have a command that says, spell check this document. And you can have a command that says, you know, sort this database, and we'll sort it database. Okay. In Python, you can write for I in range 1, 11, print I, that counts from 1 to 10. And I know that may not sound like a super awesome program, but that's a program. And then we have, these are interpreted languages, and this is how we write them. Then we have compiled languages like C, just-in-time compiled Java. We have different types of compiling. You don't know what all the need to know what all the different languages are, but it's this idea. So we have the interpreted languages and we have the compiled languages. In C, here's how you count from 1 to 10. Now, which is better program? These two programs do exactly the same thing. They count from 1 to 10. Which of these is a better program? Python or C?
I can do it simpler.
Okay. For me, I prefer Python. I actually watched a video yesterday by a guy named Linus Torvalds. Any of you heard of Linus Torvalds? He's the guy that wrote Linux. Any of you know what Linux is? It's like the 3rd most popular operating system on the planet. No, it's actually the 2nd. It is actually Macs run on a variant of Linux. And I'll tell you why Macs run on a variant of Linux, because Linux is open source. My computer is running on Microsoft Windows, not open source, it's proprietary. It's a problem. Okay, so anyway, this guy Linus Torvalds, they ask him a question, is C really the only useful language for writing operating systems? And say, yeah, pretty much it is. Meaning he likes this kind of stuff because you have tremendous control, but at a cost. Okay, so Gabe, you asked the right question here. Better based on what dimensions? For simple people like me, I like a language that I can write things simply. 2 lines of code does a lot for me here. So I can never remember my printf things, whether it's %d or %e or whatever. Okay, so then we have assembly languages. Assembly languages are getting closer to what the computer understands. Now, does the computer understand for or print or anything like that? Absolutely not. The computer itself, meaning the chip inside the computer, does not know what print means. Yet print means a whole bunch of things that it does. So we use high-level languages so we don't have to tell it. Now, to print from my computer to a printer, which I don't have a printer in this room, but if it's doing it over Wi-Fi, what it actually does is it takes what I want to print and it puts it in some kind of a byte code, then it formats it and puts it in packets, and then it sends it over a Bluetooth or an internet connection that then is unbundled as packaged and reassembled and put into some type of a compiler that puts it in the, I mean, it's super complicated. To print a 1-page document probably is 1 million lines of computer code, a 1-page document that has to execute. A million, not lines, but executions of computer code. So that's assembly language. And I gave you some assembly language in the chapter. Did you see that there? It is super cryptic. Back in the 70s, when I started computer programming, we programmed in assembly language. Nuts. Okay, it was nuts. And then you have machine code. And this is like assembly language is different computers here. These are different chips. Machine code is actually like this. It's a bunch of numbers. And this number here means set the variable register B to the value EC. I don't know what it means, but the computer understands it though. And then finally at the bottom, we have binary. Now, actually, the computer doesn't understand 4 and 8. It turns out our computers in this room, all they understand is 1s and 0s at the end of the day. And that's what the computer understands. So what's the difference? So there's a spectrum here. This is source at the top. This is executable at the bottom. If all we have is source, the computer doesn't have anything to do with it. Can't do anything with it. It's gibberish to the computer. If all we had is binary, it's gibberish to us. So we have to bridge the gap. And that's what interpreting and compiling does. So that's this open source is all about this. So these are understandable by humans, and these are understandable by the computer down here. So we have to bridge this. There's actually a new one that I added to this list. It's higher level languages, which is natural language processing, which is, I'll show you. I'm going to write a program right now. Is that okay? Here we go. We're going to write a program. Count from 1 to 10.
Asking me to
No.
Please tell me what you, for example, do you want?
Just count from 1 to 10.
1, 2, 3, 5, 6, 7, 8, 9, 10.
That's a program. It's a natural language program. That is the new thing of this era, is that now you can actually write programs. It's called a prompt. Prompt is really nothing more program written in whatever language you speak. Okay. All right. So count from 1 to 10. I already did that. So this is source up here. This is source. It's where this comes from. That's the source. This down here is the binary. We compile it from the source to the binary, and you can run the binary, and the computer understands it, unless it's interpreted. Now, the difference is, let me show you this difference. If we compile, you have the source, you compile it, you have the machine code, that stuff at the bottom, and then you can take that and just run it on the computer correctly. With interpreted, you have the source code, and at the time you run it, you interpret it. That's the difference. And most of you got that question right. So I'm very pleased about that. There's another diagram. Compiled, you take the language, you compile it into machine code, and it's ready to run. Interpreted, you have the language, it's ready to run, but it has to be interpreted at the moment it's run, line by line. Does that make sense? Okay. That's key. This. So distribute it. Now the difference is, if you're distributing software, sending it out to people, if it's compiled, what do you give to people? If somebody buys your software or wants to download it and use it, what do you give them? Source? If it's compiled software, what do you give them? Hey, I have this great program that'll organize your calendar for you, or it'll spell check your document or whatever. Okay, if I want to give you this, if it's compiled, what do I give you? The executable, which is the binary, same. I give you the executable. Now, if I give you my executable for my fancy organize your calendar or rewrite your document, if I give you the binary for that, can you modify the binary? Do you understand what the binary is? It's a bunch of 1s and 0s. Yeah, you can ruin it quite easily, but you can't organize it in a useful way. Why not? It doesn't have any meaning. It's just a bunch of 1s and 0s. You need the source code. But if it's proprietary, I keep the source code. I don't give you the source code. Okay? Because it's a secret. But if it's open source, it's public. I give you the source code and the binary. Or you can make your own binary. If it's open source, everybody can access the source code. You can get your own compiler and make your own binary.
How come How come it can't be reverse engineered? If my computer understands exactly how to execute it.
Yes.
Following perfect steps.
Yes.
There must be some type of way that it's
Very good question.
making sense of it, so why can't I?
In the olden days, you can reverse engineer by decompiling. You can actually take binary and decompile it. The problem is there's a bunch of variables. Now, when you did your glyph thing, did you name your variables? What names did you give your variables? Yeah, title, caption, you know, whatever you want to name them. That has meaning. If you reverse engineer the code, it calls them variable 1, variable 2, variable 3. So you could, now I believe that if we achieve artificial general intelligence, which is like AI that's as smart as humans, no, and actually we have to be smarter than humans. You could potentially get AI that was smart enough that could figure out what variables would be. That's not going to happen the next place. So meaning you can decompile, but it's almost gibberish. It gives you a code, it gives you Python or whatever it was written in. But there's no variable names, there's no ID, no function names. We just really don't know what it's doing. Does that make sense? Until we get to the future where AI is smart enough that it says, oh, I bet this is actually called, you know, title, and I bet this variable is called whatever. Question, excellent question. Are there any other questions about this? Okay, interpreted, you distribute the source code. So for example, in your browser, if you run code, which you do all the time, almost every website uses JavaScript in the website. You can actually hack in. You can't keep that a secret because JavaScript is interpreted. And the only way to get into your computer. So you know what they actually do with JavaScript? They have this thing called minimize it. It takes all the variables and changes their names to gibberish. Instead of saying title, it says variable A, variable B, things like that. And if you look at it, you can't really tell what it's doing.
That would be under like if you go to inspect element or whatever.
Yes. If you want to inspect, you can actually go in and look at, or view source as well. And you know, you can actually look at the JavaScript. Okay, why does it matter? So running locally versus in the cloud, we're going to talk about that in 2 weeks. No, 3 weeks. We'll talk about implementation. I think it's maybe 3 weeks from now. We're going to talk about cloud versus locally. So do you run it on your computer or do you run it at a distant workstation? Right now, if we're using GPT, we're using all those at a distant workstation. Now, there's other models we want to run on a local computer. And one of my goals, and in fact, we're going to talk about this right at the end of class today. One of my goals this semester, I've had it the last 2 semesters, which is to come to class and we're going to have a practice running things locally on our own computers, running large language models. Have any of you tried that yet? Anyway, I want to do this. I've been just waiting for the hardware to catch up with us. There's this thing called the NVIDIA Spark. They keep telling me it was supposed to come out in March, then it was supposed to come out in August. It still isn't out yet. But I want to buy one of these things for $3,000, bring it to class, and we're going to run OSS or some big awesome large language model on it in class. So that's one of my goals. I'll talk about this in 10 minutes. All right. So that has to do with modifying and copywriting. We'll talk about copywriting at the end of the semester. So we have source code. You can compile the source or interpret it. You can see it. You can verify it. Okay, you can tell, is it stealing data? Is it doing devious things? If you have the source code, you can trust it. Nobody would have used DeepSeek except for one thing. It's open source. If it wasn't open source, if it was only binary, nobody would use it. You know why? They would be paranoid that it was stealing their data. Any data they put into it, it was secretly passing them to somebody that was using it for purposes. But because it's open source, we assume somebody's looked at the source code. And yeah, this is legitimate. Does that make sense? That's the value of source code. You can modify it. If you don't like it, you can modify it. Was Hugging Face in this week's? I think it was, wasn't it? How many modifications of DeepSeek are there on Hugging Face? Yeah, a lot. How many is a lot? Okay, here I'm in DeepSeek, and I go under models, and I'm going to search for just DeepSeek. Okay. Oops, that's not what I wanted. It gave me actually DeepSeek. Well, what I want is these variations of it. Right now on Hugging Face, there are 2,115,745 models. That's how many models there are. And you can download any of these. They're all free. You know what? There's not that many different models. They are modifications of other models. Look at this. Quen, there's Quen, instruct. Here's another Quen, thinking. Here's another Quen, image edit. Here's another Quen, instruct. Here's another thinking. There's everybody's models. They just take the models and download them and create their own version to do what they want. They fine tune them, which is what we're going to do at the end of class today. Okay. Binary, you can run it, you can decompile it, not very effective. You can see what it does, but not really how it works. Kind of a black box. So that's the problem with binaries. And proprietary in general is we kind of know what it does in terms of inputs and outputs, but we don't know how it does it. Does that make sense? Closed source, secret, proprietary, only distribute binaries. I already talked about all this stuff. Helps create you can make money with closed source or with proprietary. Open source, you can still make money, but it's harder to do that. An example is Canvas. Who makes Canvas? Anybody know? Instructure. It's a company up in Pleasant Grove. They make Canvas and they make it open source. You don't have to pay to use Canvas. You know how Instructure makes us Google out the money? Hosting it. They'll run it on their computers for you, or in the cloud, Amazon or web service or something like that. So they'll run it for you and they provide phone support for you. And they charge you a lot of money for that. But if I wanted to, I could say, to heck with them, I'm just going to run it on my own computer. And you can just download it and do it because it's open source. The advantage of that is anyone can modify it and anyone can share their modifications. If I download it, depending upon the license, if it's a copyleft license, I have to make my modifications public. I cannot have them be proprietary. Bummer. It forces, once it's open source, copyleft licenses force it to stay open. Various licenses. This is Richard Stallman, the kind of the father of free software. There's the MIT, there's the Apache. MIT is pretty strict. I shouldn't say strict, pretty strict in terms of being open. There's GNU, which is copyleft. So once it's GPL, it's always GPL. The problem with the general public license, the problem with this was, if you have a big piece of code and you add one piece of open source to it, it kind of is like a virus that makes the whole thing open source. People didn't like that. So somebody came up with a lesser GPL, which says you can have open source and proprietary together, and the open source does not force the proprietary to the open source. Yeah. And then Apache, another one here, right? Or OpenRail, that's kind of a new one. That hasn't really taken off yet, but it's licenses. All right, any questions about that? Okay. In the chapter, it talked about which is better, proprietary or open source. So let's kind of finish this discussion, and then I want to talk about another thing we're going to do. We're actually going to do one little activity. Give me some thoughts about why you would want to choose open source over proprietary or proprietary over open source. Right now, my suspicion is you're all using proprietary. Any of you tried using any open source? You can do it, like go to Meta's site. If you go to meta.ai, that's an open source software you're using there. Why are you all using proprietary, not open source? Yeah, you don't have to deal with it. Now, there are places where you can access, like at meta.ai, where you can access open source stuff on other people's machines. Well, they will host it for you. They can do open source. So for example, if I go to Meta AI, it's running the Llama model, which is also an open source model. I could use their server or I could do it myself. So we do proprietary. Why are we all using proprietary? I use almost all that I do is proprietary models. Why do I do that?
I feel like businesses, like if they want to make money, they're going to try to do what is the best models.
Yes.
And so by using those models, we get the best.
Excellent. So that's one of the major reasons. Is currently the companies that are selling proprietary software, it has to be the best. They have a monetary incentive for that, to be the best. Now, open source, on the other hand, it tends to be volunteers. It tends to be people that are, and truly Meta has made open source software, but the day's coming now where we're starting to see them move to proprietary, so they can make that. So if it's proprietary, you have a monetary incentive usually to make it better. Good. What's the incentive to make open source better? Make better software that's open source. By the way, who tends to be the ones that improve open source software? Who tends to be the ones that would improve open source software?
Other people.
Yeah, other people. Who? What other people? Users, yes. They use it and they say, oh, I want to improve this because it makes it easier for me. That's called the open source community. You ever heard of that? The open source community? I mean, it's not really a community like, oh, hey, it's the neighborhood and, you know, you go in and they have, you know, parks and streets and sidewalks. No, it's not that kind of community. It's just basically people who flock together, like all these people on Hugging Face, and come in and say, hey, I can improve this model in some way. I can have it speak, you know, Swahili, so I'll actually train it or fine tune it on a particular thing, and then they throw it up there as open source so that other people can access that. So it tends to be, I don't want to say altruistic, but it tends to be people that just want to improve the software in general, so it's better software. But again, it can be challenging to have, without monetary incentives, to help control that quality. It's tend to open to kind of what we call crowdsourcing. That's that. So here's the challenge. Why did DeepSeek, why was it so disruptive back in, what was it? Last year, 24 that it came out, I guess. Sometime last year. Reason DeepSeek was so disruptive was because for the first time, an open source product competed on benchmarks, meaning measurements, proprietary models. Blew people's minds. The fact that it could actually do as well, a lot is MMLU, and there's other benchmarks that actually do as well. And what happened is that the trillions of dollars in companies like NVIDIA and even Microsoft and other companies that are in AI space right now, a lot of that is built upon the trillions of dollars of market valuation of these companies. It's built upon the idea that they will have better models. And if somebody like, I can't remember the name of the company, Star something, you know, with DeepSeek, a Chinese company, if somebody can come up with a open source model that's as good as the expensive models, the billion-dollar models, holy cow, it's disruptive. Because now people are going to be saying, wow, why should I be paying hundreds of thousands of dollars to these companies to do all of my inference on the models when I can do it myself for a fraction of that cost? Does that make sense? So this debate is going to continue. I see it swinging back and forth between proprietary and open source, and, you know, decisions about what are we going to do. Now, the last topic I want to talk about today, we talked about this back in chapter 2, and I have a little exercise I'm going to have you do. In fact, I'm going to have you do it now. I've budgeted the last 15 minutes of class to do this little exercise. It's not going to take the whole 15 minutes, but it's because I want to do something that will build on this in a few weeks from now. So I need you to do this now. It is a, you can turn off the video now, Peter, because this last little part isn't really. All right, so let's go to